Hi, I'm Stacy Finley. I'm an assistant professor of biomedical engineering at the University of Southern California in Los Angeles, California.
Thank you. So, Stacy, tell us a little bit about this new and exciting award that you just received from your university.
Yes, so this award is the Leah Edelstein-Kershet Prize from the Society of Mathematical Biology. So this is a national or international actually organization that's focusing on mathematical approaches and mathematical analyses of biological systems and just biology in general. And so this organization has been in existence for several decades, and Dr. Edelstein-Kershet was the first female president of the Society of Mathematical Biology, and that was in 1995. And even before then and since then, she continues to be a pioneer in the field of mathematical biology. So this is the inaugural year for this particular prize, which is being awarded to a junior faculty member or an early career faculty member who's building an independent research program in mathematical biology. I'm very honored to have been selected as the inaugural winner of the award. And so it's primarily recognizing work that I started doing as a postdoctoral research fellow at Johns Hopkins and that I'm continuing to do now in my own research lab at USC, where we're building mathematical models to better understand angiogenesis. And this is the process by which new blood vessels are formed from pre-existing vessels. And the models that we're putting together are being applied to better understand the effects of therapeutics that are aimed at inhibiting angiogenesis in the context of cancer. So in tumors, they exploit this very natural process that happens under normal physiological conditions, but the tumors exploit this process in order to get the oxygen and the nutrients that the tumor cells need to grow and continue to proliferate. And so there are a number of therapies that are aimed at inhibiting angiogenesis, so the formation of these new blood vessels in the tumor, as a way of preventing the tumor from continuing to grow. And so we've been putting together mathematical models to better understand the effects of these therapeutics and also to understand how different tumor types will respond to the therapy.
Excellent. Not too many biologists like math, so this is great. So how did you start on this career pathway, combining computational math and biology?
Sure. So my background is in chemical engineering. So my undergraduate degree and also my PhD are both in chemical engineering. And it's actually from since I was in my senior year as an undergraduate student, I went to Florida A&M, a historically Black college in Tallahassee, Florida. So when I was at Florida A&M, I did a research project with a faculty member there in my senior year. And it's there when I got really excited about doing mathematical modeling. So we were still studying biology, but in this case, we were studying goldfish skeletal muscle. So again, it had applications in just better understanding how drugs or molecules are diffusing in these skeletal fibers and how we can better understand their distribution in order to, develop more effective therapy, specifically gene therapy. And so it was really from that experience that I got really excited about using some of the core like calculus and fundamental mathematical concepts to study biology. And I also feel like because biology is so complex, it's really ripe and prime for applying mathematical analyses to this so that we can try to put in as much knowledge as we know into a model such as this and be able to better understand the complexity and the interconnectedness of all of these molecules that could be involved. So it really started as a research experience as an undergraduate student. I decided to pursue graduate work and still focus on mathematical modeling. And then that also transitioned into a postdoc in biomedical engineering. And so it's always been, wanting to apply mathematical analyses to different biological questions. And so now I'm just really excited to continue doing this work as a faculty member as well.
Good, thank you. So what is the one, I guess, most important or most significant advice you would give to a younger trainee, even in terms of pursuing a career like yours, a pathway just like yours?
Sure. I think one thing that I really try to do as a graduate student is not turn away. So as soon as some barriers came up or difficulties came up, it's very easy to just say, oh, well, I don't need to do this. I can figure out something else to do. And so my advice to, colleagues who are going through the graduate program with me, or new students who are coming through the program, and even the students that I'm training now, is don't turn away when the difficult issues and the difficult circumstances come up, because that's really the time when you're testing, what type of student are you? What type of researcher are you? And that's also the time when you can really shine even more brilliantly. And so I say just press through and keep pursuing your passions.
Well, thank you very much. This has been a very enlightening and I think very exciting time for you and for us in the Fellows Program. We are so thrilled for you and look forward to hearing more great things from you.
Thank you.
Thank you.